Hey, also, we're looking at 5C homework here. Now, if y'all got questions on 5A and 5B, if y'all haven't looked at it yet, look at that stuff. And then Wednesday, I can go over any questions on 5A and 5B, okay? Reason I'm focusing on 5C, like I said, is this is where you're going to learn how to do a frequency table, okay? All right, so two things you see in this section, it starts out with going over definitions. So statistics is where you take a lot of data and you try to find out different information. So there's two types of data. We got qualitative data and we got quantitative data. All right, so when we talk about qualitative data, we're talking about categories that are being described. So this describes categories. Now, by categories, I'm talking about the color. So you can look at eye colors. If you had a movie theater, you could look at the different movies. Okay. If you're looking at clothing, you could be looking at shirts versus pants versus other clothing. Okay. So qualitative data describes things like color and stuff like that. Quantitative data, this represents counts. So this describes counts or measures. Okay. So quantitative data could be amounts of paychecks. It is an actual number. Height of basketball players. The height is an actual number that you can measure. Okay. All right. So y'all, that's the two things they're going to be looking at. So let's start this homework by going to it. And I want to show y'all 5C homework and see what y'all think on some of these. So what is this distinction between qualitative and quantitative data? So we said quantitative data describe categories. Quantitative was the measures. So they're starting off, quantitative describes categories. Well, that's false. Quantitative describes categories. That's false. So it's got to be C or D. Qualitative describes categories, while quantitative describes counts or measures. All right, so then it says brand names of shoes and eye colors are examples of quantitative. Heights of students and quiz scores are examples of qualitative data. So would we go with C or would we go with D? The difference is on D, they're saying brand names of shoes and eye colors are qualitative, while the heights and the quiz scores are quantitative. So y'all chat me your answer. Would y'all go with C or D? So let's see. So C says brand names of shoes and eye colors are examples of quantitative. But y'all remember, we just said um, quantitative represents counts or measures. Qualitative describes categories. Well, y'all, eye colors and brands of shoes, you can't measure those. So those would be your actual qualitative, to where the heights of the students and the quiz scores are going to be your quantitative because those are things you can actually measure. So y'all not C, but you got to go with D on that one, okay? And it's not in the definition, it's in the examples on that one, okay? All right, y'all, so this one, describe whether it makes sense or not. So they're talking about relative frequency of B grades in our class was 0.3. So relative frequency, if you got a set of data, the relative frequency is how many times that it happens, okay? How many times does something occur in a data set? So let me write some of this down for you. So like I said, the relative frequency. So if I was given a lot of data for the grades of my students, I might have so many A's, so many B's, so many C's, D's, and F's. So the relative frequency is the number of times an item shows up in a data set. Now, to get the actual relative frequency, we take the number of times the data showed up divide that by the total number of data and we multiply that by 100%. Okay, so that would be how you find your relative frequency. Now, frequency is the actual number of times it shows up. So like if it showed up 5 times is the frequency. The relative frequency, we would take the same thing, but write it as a percentage of the data, okay? So let's go play with that question and see if that question makes sense or not, because that's what they want us to say. So the relative frequency of B grades in our class was 0.3. So say you got 10 students in the class and the number of B's you had was 3 B's. Well, 3 divided by 10 would give you 0.3, so that makes sense because the number of B's would be less than the total of all the scores. So it sort of makes sense as long as that 0.3 ain't over 1, any of these could make sense, okay? Now, I got B and C. So they're saying there's 20 people in the class. If 6 receive B's, then the frequency would be 6 divided by 20, which gives you 3.3, which is basically what I was doing with 3 out of 10, same average. But look at this C, what they're doing. If 4 received B's and 2 received A's, then the frequency of B grades would be 4 plus 2 over 60. Well, y'all look at that. That's not the relative frequency of B grades because they're adding 4 B grades with 2 A grades to get that. So that's not the relative frequency of B grades. So that one is false. So we would have to go with B on that, okay? So what y'all think here? The cumulative frequency of C grades in our class of 25 students was 48. So let me give you one more definition, and that's the cumulative frequency. So y'all, the cumulative frequency basically is adding up all of the frequencies you got. So if you had 3 A's, 4 B's, 6 C's, it adds that total as you're going down through the list. So it equals the current row's frequency plus all prior rows. So y'all, let me give y'all an example here, okay? So grades, this would be the frequency. We're going to figure out our relative frequency. And then our cumulative frequency. So say I had some grades. And on them grades, I had 5 A's, 6 B's. Oh, my C's were down to 4. D's were 2. And F, I had 1. So y'all, let me pull that down where y'all can see that better. So this is the frequency of each of my scores. I had 5 A's, so it happened 5 times, 6 B's, 4 C's, 2 D's, and 1 F. So my relative frequency is going to be like a percentage. So let's see how many we had total. 5 and 6 is 11, plus 4 is 15, plus 2 is 17, plus 1 is 18. So in total, we had 18 grades. So to figure out the relative frequency of A's, we take 5, divide by 18, and then multiply by 100%. So once we divide that and multiply by 100, we'll have our relative frequency. All right, y'all, so I'm going to just pull my other calculator up here. All right, so we had 5 divided by 18, enter, and then times 100. That's going to give me 27, and we're going to round 1 decimal place. So that'd be 0.7, but it's got a 7 after it. So we'll make that a 0.8. So that's going to be 27.8. So that means 27 0.8% of my students were making an A on that. Now the cumulative frequency is the frequency of that row, which is 5. And there's no prior rows, so I'm good. So now let's do the B's. Total, my relative frequency will be 6 divided by the total. So 6 divided by 18 times 100%. Oh, remember, that's in percent now. All right, so same thing we'll do. 6 divided by 18. Take that answer times 100. And we get 33.3. And we'll keep that at 3 because of the 3 after it. So basically, a third of my students made a B on that test. Now, the cumulative frequency would be the number of the frequency on this row plus my prior rows. So this frequency is 6, but the prior row had 5. So my frequency for cumulative frequency is now 11. You add your row plus any prior rows. Because when we're done, this cumulative frequency has to equal 18 because that's the total students we had, okay? All right, y'all, for C, we had 4. So that'd be 4 out of 18 times our 100%. So 4 divided by 18 times 100% gives us 22.2%. All right, cumulative frequency. The frequency of this row is 4. So now I add the row prior to it, which was 11. So 4 and 11 now give me a cumulative frequency of 15. So see, I took the cumulative frequency, added 6, got 11. I got 11, add 4, I'm now at 15. Okay? You're always adding it to the one before it because that's the current cumulative frequency. And we're just going to keep adding as we go. All right, y'all. D, we had 2 out of 18 times our 100%. So 2 divided by 18 times 100. That's going to give us 11.1%. So, what is my cumulative frequency? So y'all can answer that on your chat there. Let me pull my chat up. All right, y'all. So what are y'all putting for my cumulative? So what you got, Morgan? 17. Good job. Because this 15 plus 2 gave us 17. All right, y'all. Look at that. F, 1 out of 18 times our 100%. So 1 divided by 18 times our 100%. Looks like 5.55, so I'm going to make that, what, about a 5.6%. All right, so my final cumulative frequency is now what? 17 plus the 1, which is 18. So now if you add my columns, this would equal 18. My last cumulative frequency was 18. And y'all guess what? If you were to add all these percents, all those would add up to 100%. Okay, so frequency is how many times it happened in my data. Relative frequency, I took how many times divided by the total, and then multiplied by that 100 to get it in percent. And then cumulative frequency, we were just taking the frequency from the current row. Now, if I was on the second row, I was taking my current row plus my prior row, okay? All right, y'all, so I got them out of the way. Let's go see what we're going to do with this homework here. So look at this. The cumulative frequency of C grades in our class of 25 students. So you got a total of 25 students. They're saying the cumulative frequency was 48. But y'all, that can't make sense, right? If you only got 25 students, there's no way you had 48 C's. So that's definitely wrong because your cumulative frequency can never equal more than the total students, okay? So it does not make sense. And then here we say what the frequency cannot be higher than a total. D don't make sense. It don't matter how many got B's on this, it ain't giving us our C frequency, right? So you just sort of gotta think about what your definitions were and then see if those make sense or not. And y'all, this is another one. Does it make sense or not? Your pie chart must be wrong because when I added up the percentages of your wedges, they totaled 124%. Well, y'all, here's the thing. When you add up all the wedges of any chart, whether it's a bar graph, pie chart, if you're showing percentages, you cannot go over 100%. Okay? If you got all your data percented it out, then it cannot go over 100 when you add them together. So that's definitely wrong. So this person must be right. It does make sense. And they're telling why it makes sense because the total of 124 cannot be higher than the 100. So, A says does not, I would go to B. What's that say? It makes sense. In the total relative frequency, remember we said a while ago it had to add up to 100%, okay? So I'll definitely go with B. Let's see what D had to say. Oh, and they're saying the relative frequency must be 360. Well, y'all, the only person that cares about 360 is probably a circle, okay? So not in statistics, that data there. All right, now, so here's one we're actually going to make a chart out of. So, y'all, I got my chat going. Let's see how many grades we got here. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We got 24 grades here. Okay? 24 letter grades. So the first thing we want to know is how many of those are A's? So we're going to count how many A's we got, y'all. What do we got? So we got 3. So y'all, we're going to put a 3 there. Now the relative frequency, I need one of y'all to do 3 divided by 20 and multiply that by 100. All right, y'all, so what are we getting? 15, good job. So that came out to 15%. And y'all, what are we putting on the cumulative frequency on my first row? So Michael, 3, good job. All right, y'all, when you check that answer, it's going to go to the next row for us. Whoops, what did it not like? Oh, I don't like my second answer. Let me see what happened here. Didn't we get, let me see if they want this in decimal. Sometimes this thing's crazy. Let me see. All right, we had 3 divided by 20. Y'all hang on, I want to see what's happening there.
Shouldn't it be 24? 3 divided by 24?
Oh, I gave y'all the wrong number, didn't I? Okay. Okay. Woo, we had more than 20. Griffin, that was my bad. My bad. So that's 12.5, y'all. So that's what y'all should have got. Okay. Well, I know I said 24 and then I used 20. My bad. All right, y'all. We're going to get it right now. How many B's? I wish I'd have looked at my chat before I did that last one. All right, 8 B's. All righty. All right, y'all. How about 8 divided by 24 times 100? We're rounding it 1 decimal place if it does come out as a decimal. So 33.3, perfect. Now, cumulative frequency. See if y'all remember this one. All right, Michael, 11, good job. So let's check answer. So y'all, they work out nice as long as you use that 24, right? All right, y'all, next row, we got C's. All right, 7 looks good. Relative frequency. So that'd be what, 7 divided by 24? Times y'all's 100. Oh, and that's a good one because you got around that 1 decimal place. So 29.2, that's what I'm looking at. All right, y'all, cumulative frequency. All right, good job, 18, because it's that 7 added to that 11 prior. All right, y'all, looks like we just got a couple more categories here. We got our D. And what's that? 1, 2, looks like 5 on that one, right? All right, relative frequency, you got 5 to 24. All right, what y'all got? 20.8, good job. And y'all, my relative frequency at this point. 23, perfect. All right, y'all, there's the Fs. Hopefully they're not as high, right? So I'm only seeing one F. So the relative frequency of one F so 4.2, good job. And y'all, my final cumulative frequency. And Megan, good job. It's got to be 24 at that point because that's our total number of grades we had, okay? So now, they just want to show y'all what happens. What's the total of that first column there? Add your A, B, C, D, F's up and tell me what that total is. All right, you got 24. And then over here, your final cumulative frequency was also 24. So y'all, they just want y'all to see that those are going to match up when you're done with a frequency table. Now y'all, let's see if this is a qualitative or quantitative. Is it describing categories or is it a measure? Okay. The flavors of ice cream sold at a delicatessen. So first off, you want to know, is it qualitative or quantitative? And then they sort of tell you why here. So flavors, well, you can't measure flavors. Flavors are always that flavor, right? So you can't measure them. So they definitely got to be qualitative, talking about the quality of the ice cream. So it's either A, quantitative, or B, qualitative. So it looks like A, right? Non-numerical categories. It don't ask nothing about how good the flavors were or anything like that. So we're not worried about that. That'd be maybe a survey if you were asking people what their favorite flavors were, maybe, but yeah. So just trying to figure out which one they're talking about for your meaning. And then what about this, qualitative or quantitative? The annual salaries of NBA basketball players. Well, now you are talking about some numbers, right? So A, quantitative, good job. So we either got A or B. And B don't even make sense because there are a limited number of players on each team. Well, that don't matter. They're just worried about the annual salaries of NBA players on average. So that'd be A, right? Because it's our numerical categories. And we can find out things based on them numbers. We could do an average of all the salaries and see what their average salary was. We could look at statistics like what was the salary of the top 10% of basketball players. You know, the ones that make the multi-million, multi-year deals versus your reserve players and stuff. So we can take numbers and do a lot of things with them, y'all. All right, y'all, let's see what's next. All right, now look at this, y'all. They gave us some data here. Now they're saying use 10-point bins. What that means is the range of numbers that you're going to do is going to range and differ by 10 points per category. So look at my first category. It says the data 90 to 99. So my first bin is basically doing the 90s. So I need to see how many of my data fall in between 90 and 99. So y'all, let's count 93, 92, 97, 92, 90, and then 98, 97, 99, 95. So Griffin, what'd you get? 9 there? Looks good to me. Now remember, my relative frequency, I got to see how many total I got. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So this time we do have 20 on this one, okay? All right, y'all. So relative frequency for 9 out of 20. And then multiply that by that 100 also, remember. So y'all punching that in, that looks like 45% looks like to me. So that means at that point, I'm looking at that 45%. Well, y'all, 50% is half. So this is telling me almost half of this data is in that range from 90 to 99, okay? All right, y'all, cumulative frequency is going to equal the frequency. So there you go. All right, y'all, now they're doing 80 to 89, y'all. So how many we got between 80 and 89? So let's see, I got 87, 82. Oh, and I do have a 85. So it looks like I got 3 of them in between that range. So now we want 3 divided by 20 times our 100. And y'all, that one I think we're getting about 15. All right, y'all, cumulative frequency. Okay, Michael, I thought you was doing some Mississippi math on me there for a second. Okay, y'all, so that would be 12. Good job. So remember, it's that 9. It's the 3 plus the 9 cumulative above it. All right, y'all, 70 to 79. So yeah, I'm seeing 3 again, Michael. So let's put a 3 there. Well, I bet y'all know the relative frequency for 3. And y'all, since I had a 3 right above it, I'm going to put a 15 again for that. And how about that cumulative frequency? So let's see, Morgan, you got a 15 there. So let's see, 12 and 3 is definitely 15. All right, looks like my last bin is going to be 60 to 69. So y'all getting 5 on that one. All right, the relative frequency for 5. So 25. So that means a fourth of them were that range. And then my final cumulative frequency. All right, Griffin, 20 on that one. All right, now, and then you know they're going to make us add that up. Now we know the final cumulative frequency over here was 20. So guess what? Add that first row, and we know what we're going to get there. Let's see, Michael, what y'all got there? 20. There you go. So the total when you're done is going to equal that cumulative frequency, okay? All right, y'all. Now, these are some of the graphs they're talking about. So a bar graph is using bars. The bottom has your categories. The side over here where the y-axis is at is your population in millions, okay? Now, they want to know which one of these could I use of the 5 most populous states in a certain country with the bars in descending order. Descending order means they start with the biggest bar and they go downhill to the right. Now, if they start with the small bars and go uphill to the right, we call that ascending. But descending will start with the bars on the left and go down to the right. And then you always want your categories in a type of order, okay? So what do we got, Michael? F. So F. Yeah, look at that. Y'all just got my categories listed. And then now, the reason I'm not picking, well, let's see which one we picking. See, look at the chart over here. See where it says state A, B, C, D, and E? A is the biggest one at 36.7 million. So if y'all look at F, A is the biggest one. If you look at A over here, Griffin, the biggest one is actually being shown to be E. Well, if you look over here, E would actually be your smallest category. So you sort of want to use that little chart there to figure out the order of your variables, okay? So it looks like A is the biggest, then B, then C, then E, D, and then E, okay? So just watch out for that order. And then y'all, this last one deals with sort of like a pie chart. So the pie chart for the percentage of mothers between 40 and 44 in a country with various numbers of children. So now the charts represent over here to our table the number of children, 1, 2, 3, and 4 or more, and then percentages. So look, the biggest percent is going to be 2 children. So you want to find a chart, and it looks like 2 is orange on all of them. So the orange has to be your biggest section. So that's going to be B or C. Now, let's see what they're doing different. So they both got blue the same. So it looks like the differences are in the green and yellow, right? So Michael's going with C. So let's see. So 3 has to be bigger than 4. So green has to be bigger than yellow. Good job, Michael, because over here in 4, they got yellow bigger. We needed the green to be bigger. So y'all, you would pick C and check your answer. All right, y'all. So that is the 5C homework. I just wanted y'all to really to get familiar with them frequency tables. They're not bad once you play with them a couple times, okay? 5A and 5B mostly is just more type definition stuff, getting you used to statistics. And like I said, if you got questions over either of them, I'll go over those on Wednesday with you. And y'all, let me see one thing here real quick. There's really not a quiz due for this week. It's just mainly support 5A and then 5A, 5B, and 5C, okay? And like I said, next week we start getting into chapter 6. We're going to learn about mean, median, mode, how to make box and whisker plots, all that fun stuff, okay? So mainly this week you're focusing on the chapter 5 material. All right, y'all. So, any questions for y'all? Y'all realize we're after this week we'll be halfway done with this course, okay? So we're on our 5th week out of 10 now. So y'all, yeah, I'm gonna do an email about that. But yeah, since y'all are all here, the budget's gonna be due, is that the 30th, I think it is. Yeah, so budget will be due June the 30th. Um, and y'all, you're just copying that data like we did on our budget that day, making a few changes so that they can have a positive cash flow instead of negative. And then there were just a few questions, okay? So use that Excel file and put in all the data, then sort of copy that onto another page of Excel and put your changes, okay?
Oh, I have a question. Can you hear me?
Yeah, I hear you.
So I go by the data that you already was working on. I don't do my own, right?
Right.
Ooh, okay.
Now, if you wanted to make a copy of that and sort of do your budget, I could use that sort of like bonus points in places, if you wanted to go above and beyond.
I'll have to see what I'm working with first.
Yeah, them things are sort of tricky. But if you want to do it at home for like a private, you can change some of them categories, look at what you're making, what your bills are, um, their insurances and all that fun stuff, and average it out. And then you can sort of play with that at home and have a little budget helper, okay?
Okay.
Um, yeah. And the main thing we use that's it sort of gets y'all into Excel a little bit and seeing how to play with Excel. And Excel can be what do you call it? Real time type when you're putting in data, you're getting them immediate changes and everything. So all right, so notice y'all, we are into our statistics stuff now. So not too bad. It's just a lot of the biggest thing about statistics to me is if you got a lot of data, it can be a lot of work. But that's how you get more accurate, the more data you got, okay? So y'all, I'm not seeing any questions, so play with the 5 homework. And like I said, if you got any questions on stuff, we'll go over those Wednesday afternoon at 3 o'clock, okay? All right, y'all. See y'all in a couple days then. I'm gonna stop my recording and then I'll send this out.